Okay, so it's starting up. Meanwhile, let me get my screen share. Okay, so it's starting up. And all right. Yeah, my son and I are huge SpaceX and fans. Actually, we're all Elon Musk fans here. So he's he's graduating this year as an aerospace engineer. He hopes to be working for SpaceX at some point. We'll see. He wants to escape the planet. All right, let's see. Let's close this up. And all right, welcome everyone. So today we're going to get started on the 4th week. Wow, it's already what, a month already with the into this course. And let's see, something on the chat. Oh, thank you. Yeah, so let's just review back up where we've been. So the first week we introduced just simple HTML, some CSS, and we worked on that in our first assignment, HTML and CSS, where we built a small little prototype on some static pages and learned about how to do things responsive. We used Bootstrap to declare rows and columns so that as you change the width of the page adapted to that size, so that you can use the same exact code base, right? So that you can see it on a desktop, right, or small tablet, or even in a small phone, right? So that was the focus of the first assignment and the first week and a half or so. We and it was all static, right? We then introduced the last week, the 3rd week, we played around with JavaScript, and this is our first chance at making things dynamic, right? So we're learning on how to use JavaScript and jQuery for manipulating the user interface, right? By manipulating the DOM, right? We saw that when the browser parses the HTML, parses the JavaScript, parses the CSS, what it does is that it creates an object model in its memory, which we call the DOM, the DOM. And then that was that object representation is what drives what you see on the screen, right? And what JavaScript allows you to do is to dynamically, programmatically manipulate the DOM. And as you manipulate the DOM, you're manipulating the user interface, right? The DOM is made up of all these nodes that contain other nodes, right? It's a hierarchical structure, like tree structure, that you manipulate programmatically using JavaScript, and then you interact and then you generate a different content in the UI. We introduced jQuery as a thin layer on top of JavaScript because we talked about a little bit of the history of the language, that it had fragmented because of in the browser wars. Different vendors were competing and trying to pull developers on their side, and they started adding different capabilities to JavaScript, and this became a nightmare for developers, us developers that wanted to create these applications, and then dealing with different versions of the language, different vendors, different browsers. So jQuery allowed us to provided a small thin veneer on top of the JavaScript language, so that we could go through jQuery, and then jQuery would then jQuery is JavaScript, obviously, right? But instead of you calling the native browser specific functions to manipulate the DOM, because you were not guaranteed that certain functions would be there or would behave the same, jQuery allowed us to forget about that, right? Let jQuery deal with those underlying differences between the vendors, and as long as you understood what the functions, the jQuery functions, how it worked, you could think about the browser as a virtual browser, right, as opposed to the underlying bare bones JavaScript browser. Anyway, so that was our first foray into introducing a layer of abstraction on top of the low-level HTML, low-level CSS, where jQuery allows us to think about the browser at a little bit of higher level, right? So today we're going to introduce a new technology. Well, today and all this week and the next couple of weeks, we're going to be introducing even higher level of abstractions, and in particular, we're going to be talking about React.js. React.js is a huge leap of abstraction, right? Where we're going to be able to think about the web pages and dynamic content generation. We'll start to think about it in object-oriented terms, right? As components or reusable components, so that instead of having to code things over and over, we can use small little Legos, right? That we can build more complex applications in a reusable modular fashion. So that's what we're going to be introducing today. Okay, before we get started, a little bit of administrative work here. Just so you know, the first quiz went out this week, and it should be available in the quizzes. If you go to quizzes, Q1 is there. You should be able to take that. And so this quiz is going to be available for the next 30 some odd hours, right? So you can take it up until tomorrow at midnight Eastern time. Okay, whatever that is in your time. So please plan ahead on taking this quiz. It'll only take you about 30 minutes. You can only take it once, and it's open book. So make sure you familiarize yourself with the slides, with acronyms. Make sure what DOM stands for, what HTML stands for, what CSS stands for. So any acronym that we've seen, make sure that you know those acronyms. Make sure that you know how buttons work, how input fields work, what the different attributes mean, right? Whether it's what title means, what ID means, what name means, okay, and your checkboxes, radio buttons. So take a look at all those slides and make sure that you're familiar with that content, and it's readily available. What else? Yeah, so all quizzes. I know that at the beginning of the semester I had said that all quizzes and exams were going to be during class time, and I think since everybody's like in a different time zone, some of you are in a different country, so I think it's easier for everybody if the quizzes are asynchronous. So yeah, so they'll be available for 48 hours. So they were available early this morning, and then all the way through tomorrow at midnight. So that's true for all exams. So that's also going to be true for the midterm later in 3-4 weeks from now. And then also the final exam at the end of the semester will also be asynchronous. What else? Any questions? All right. Let's get started. Let's see. So let's go to modules. All right, so we're covered week 1, week 2, 3. Oh, something on the chat. Let's see. How do we contest our grades? Yeah. So the quiz answers will be available after the 48-hour period, right? So you can't see your answers just yet. You probably can see only your grade. So after 48 hours, so after tomorrow at midnight, the answers will be available, and you'll be able to see, your answers versus the correct answers. And then if you have any issue, you can take a screenshot of the quiz, and I will make a post for quiz 1 and you can reply to that with with any concerns about quiz 1. For assignments, yeah. So what I'll do is I'll create a post for each one of the assignments, A1, A2, A3, A4, and you can post to that particular topic, right, for any issues you might have for that particular assignment, as well as for the quizzes. Each quiz and exam will have a specific topic, and you can answer to that. You can reply to that. Okay. Let's see. All right, so let's talk about week 4. So week 4 is going to focus more on JavaScript, and up to this point, we've been taking a look at the current JavaScript version, which is most widely available on all browsers, right? And that's ES5, right? And ES5 means ECMAScript. That's the formal name, right? ECMAScript 5. And ECMAScript 6 is the most modern version, and most modern browsers fully support ECMA 6, but there's still some lagging support through all the browsers. But nevertheless, we're making stride, and you definitely, if you're using Chrome, you can assume that it'll support the latest version of ES6. But we're trying to write code that not only works on Chrome, make sure that it works on all browsers. Okay, but nevertheless, we're going to introduce this latest version, ES6. Now, not only are we going to introduce this new version, we also want to introduce the fact that we want to run this code not only in a browser, right? Normally, we think of the JavaScript running only on a browser, right? Whereas JavaScript can also be executed just from the command line, right? Just like any other program, whether you write it in C# or Java or Python or any other language, or C or C++ that you compile and then you run from the command line. You can also do the same thing with JavaScript. And to do that, you're going to need to download Node.js. So Node.js, if you head over to Node.js, here it is, nodejs.org. Okay, you can download the very latest version of Node. Here's the current version. If you download that and install it for your particular operating system, you will be able to execute JavaScript from the command line. Okay, so I'm going to create a project now, and it'll be a Node.js project, and then we can execute code from within there. You can also execute it from any file system, right? Any file that you create, and it has the .js extension. You can just execute it from the command line, right? So let me demonstrate. So here's just any file system or editor that I might have, where I could create some example file, right? So for instance, I might create here a JavaScript file, and I might say, hello.js. And from within here, you can type code that you would normally execute on a browser. You can also execute it from the command line, right? So for instance, I can say console log hello world. You can execute this code from the command line. So for instance, if I open up the terminal, and let's see where we are. So if we go down to source, cd source, there's my hello.js. See that? So I can say, once we install Node.js, right, you can say node space and then hello.js. And there it is. There's our hello world. Okay, so you can execute code right from the command line. Let's see, is there a question in the chat? So Node.js lets us run JavaScript rather than have to run it through HTML. Exactly, right? So the only way that we've known so far, and in most, for most of the history of the web, right? We associate JavaScript as language that is the language of the web. and executes inside of the browser, usually as a reference from within an HTML document, right? But JavaScript is so much more than that, right? It's just like any other language, right? And Node.js, frees JavaScript, the JavaScript language from it, so that it no longer has to execute only on the browser. We're still going to be executing only on the browser, right, for the next month or so, right, or even longer than that, because that's where has most appeal for building dynamic, reusable, modular user interfaces, right? But after we hit the midterm and on, right, we're going to exclusively, well, not exclusively, we're going to refocus our attention to using JavaScript, using Node.js, okay? But so nevertheless, we are going to be needing Node.js installed on our machine because we're going to be starting to use Node.js to compile, to run user interfaces such as React.js, all these new libraries that are going to be using, which are user interface libraries, right? They depend on you having Node.js running on your machine, right? And the reason is that what happens is that we're going to be using some really advanced syntax, okay, such as ES6, right? Well, that's not so advanced, but it's syntax that introduces being able to create classes, inheritance, being able to import and export modules, things like that that are not fully supported by all browsers. And also we're going to be introducing JSX, which allows you to very nicely embed HTML and JavaScript together, right? In one single file, as opposed to having it's a JS file on one side and HTML on the other, and one includes the other. Well, you're going to be able to embed each one inside of the other. That's called JSX. So these advanced features are not supported by browsers. So what Node.js is going to do for us is that it's going to transpile, as opposed to compile. It's going to transpile that high-level JSX and ES6 features, is going to transpile it into a common JavaScript, into a low-level common denominator version of JavaScript and HTML that all browsers can understand, right? So it's going to compile something that is, it's using some advanced syntax, right? It's going to convert it into a syntax that all browsers, right, can understand, right? So that mechanism is called transpiling. And so, and we're going to be using Node.js to do that for us, right? I mean, you could do it manually, but Node.js can do that automatically for us. So yeah, so we're going to be using Node.js only as a build tool, as a compiling tool, transpiling tool. We're going to be using it to host our user interface, but we're not really going to be using many of its very powerful, advanced features. Not yet. We're going to be doing that in the second half of the semester. Okay, we're only going to be using Node.js for these kinds of tools. Okay, so yeah, so you'll need to download Node.js. Excellent. So now that you download Node.js and installed it on your machine, let's create a project, okay? We're going to create a Node.js project, but it's going to be a very beefy Node.js. It's going to be a very specific type of Node.js project, okay? It's going to be a React.js project, okay? Which happens to be a Node.js project, but with a lot of libraries, a lot of tools, a lot of boilerplate code that has allows you to execute a React.js application. Okay. All right. So let's do that. I'm going to close this. Close this. Okay. And I'm going to create a project. We'll play around with some JavaScript in there. We'll learn about some of the advanced features of JavaScript. And then we will start playing around with React.js proper. So I'm not sure if we'll get to React.js by today, but I want to introduce some of the more advanced features in JavaScript, and we'll do that in a React.js project. Okay, so let's see. So let's go. Oops. No, generally. So we're gonna go NEU, or maybe web dev. Where did I put my web dev? Let's go to 2021. Spring. Okay. All right, so here's where we created the Java project. In the same directory where we created the Java project, we are going to create a React.js project. I'm not going to explain React.js just yet, right? It's just I'm only going to create a project, right? And we're going to do some JavaScript coding in there and get familiar with some of the new features in JavaScript. Once we feel comfortable with that, then we will start playing around with React.js, okay? All right, so to create a React.js application, we're going to use a tool that is part of the Node.js installation, right? When you download Node.js and you install it, one of the tools is called npx, okay? This is a part of the Node package manager tool. Just like any language, right? Whether it's Java or Python or C#, any language per se is not very interesting, right? It's just syntax of how to do certain things, right? So it's not very interesting. What makes a language interesting and useful is the community around that language that creates all sorts of libraries and tools and then makes those tools available either as open source or in a store that you can purchase and whatnot, right? So definitely, Java has its community, and Python has its community, and any language that you want to learn about, usually it's a large community providing lots of tools and whatnot. Yes, well, Node.js also has a large community of folks who make a lot of the libraries available for free, and the way you use these packages is through the package manager, npm or npx, okay? And these tools can be found, right, if you search. So here's one great resource, right, nodejs.org. But also there's another really good is npm.js, right? So Node package manager, right? And here, this is a repository, right, of open source tools and that folks have been contributing, that the community has been contributing, that you can then install, that you can download all these libraries, all these modules, right, for free, most of them for free, and then enhance your project. One of the tools that is available there is Create React App. Okay, so Create React App is a tool that is provided by Facebook. So React.js, as again a little bit of history. React.js is a library. It's a JavaScript library that is what was put out by Facebook, and it allows you to build dynamic applications, dynamic web pages, using a modular, reusable, object-oriented way of thinking of your applications, right? It allows you to break up your parts of the application into small little functions, right, that you can build then together to make complex applications, right? So they put out this tool called Create React App that allows you to very quickly, get up and running with a React application, right? And you use it through the Node Package Manager tool, okay? And the way you use it is as follows. You say npx, and then you say create React app, okay? Create React app, and then you give it the name of the application that you want to call it, right? So I'm going to follow the same naming convention. and I think I made a mistake when I said 03. I thought this was section 3. Turns out there's section 1. So I'm going to fix it. I'm going to now, I'm going to change it to 01, all right? So the name I'm going to use is this. So it's web dev, and then Spring 21. And this is section 01, not 03. I'm sorry about that. My username, this is a client application. So I'm going to be working with the user interface, right? So I'm going to say that this is a client. And then the stack, the technology that is being used for creating this, I'm going to say React. Okay, so this is going to take a little bit. It's going to download all sorts of libraries from here, right? From this npm, right? So this is a repository. One great thing that you can do to get your name, known as working on projects, and it would be great if, for instance, if you build your own little tools and make them available on npm. It's free, and if you can convince enough developers to download your application, your little tool, and start using it, you could become fairly famous, right? It's definitely would be part of your portfolio as being actively generating useful things that the community might be using. So definitely, I would encourage you to to look into that opportunity. So this is still building. So we're going to be opening this up with our IDE, just like any other. Okay, there it is. And so we're going to open it. We'll say open, and we're going to head into that directory. So Janunzi, web dev. There we go. 2021, Spring 03. There it is. So the React. And let's open this up. Okay, so this is already a running React application, and just to run it, it's very simple. You use one of the Node tools, right? Which is again npm, npx, Node. All those are applications. Those are executables that get installed when you download and install Node.js, right? So npm, npx, Node, those are the three command line tools that we're going to be using throughout the semester, very, very heavily, right? Starting today and throughout the next 2 months, we're going to be using this over and over and over quite a bit, right? So npx, npm, and Node.js, and just Node, okay? So anyway, so if you say npm and you say start from the command line, from the root of your React application, right? And you say start, this boots up the Node, runs the Node.js engine, transpiles the whole code into low-level JavaScript, low-level HTML, low-level CSS, builds everything, right? And then it boots up, right? Runs a small little Node.js server, and it's hosting our index page, right? An index page, and there it is. It's a very simple Node.js application. We're not gonna touch this. Let's first talk about the new version of JavaScript because we're going to be using that heavily. So I want to talk about just the language first. Okay, we'll see a little bit of changes from what we've seen in the up to this point, and we're gonna point out some of the differences in the syntax and what new features have been introduced in the language and so forth. Okay, yeah. So let's talk about that. So a couple of things here. So I put this link to a reference that you might find useful about some of the things that it points out on different versions of. Let's see, is there? Yeah. So npm is strictly for installing packages, right? That so it downloads libraries and it copies them in your local directory, right? Whereas npx is for executing, so if there's a module that can be executed, it'll download it and it'll execute it right away, right? So npm is like for installing, the O is for executing. Yeah. So here's some examples on the differences between the version of JavaScript that we've been looking at for the last week and a half or 2 weeks and some of the changes on how is it that you accomplish the same thing, but with the new version of ECMA 6, okay? And so I definitely encourage you to read through this, but in the meantime, I've created a couple of slides that I want to go through and just present some of the things that, some of the cool things that are now available in ES6. So let's take a look at that. All right, so let's take a look at ES6. All right, so let me see if I can make this a little bigger. There we go. All right, so first of all, some changes in the syntax on how we work with variables, right? Up to this point, we've been using this variant, right, where you say variable var and the variable, and then you say the value. Okay, so there's some new new ways of declaring variables, such as using the keyword let and the const. Let's see a word here. Difference between Node and React is React hosting the, yes, React is Node.js is hosting a React application, right? You don't need Node.js to host React. You can host it in our Java server that we've been playing around for the last a month or so. We could have used our Java server, which is hosting our HTML or JavaScript or CSS. We could have used that to host our React application, okay? And I can demonstrate how to do that. It's but the Create React app already creates a development environment, right, that does the transpiling automatically. It listens for any changes in the file, and it automatically transpiles it down, and then it restarts the server, restarts the browser with your changes. So it's very, very convenient to use the Node.js tools as opposed to using Java server to host the same content. You can do it. You can manually compile your content. You can say npm build, and it creates a static version of your code, and then you can move that over and host it on on a Java server or a Python server or whatever server. It doesn't matter. Any server will do. Now the Node, what Node.js gives us when you create an application using Create React app is that it creates a small little tiny Node.js server, which is tightly bound to all the other tools and listens for changes in the file and recompiles and does everything for you. So which is very, very convenient. So yeah, so that's what Node is allowing us to do. Yeah, so the right, so this is the one we've been using up to this point, but we're going to start abandoning this syntax, even though it's still supported, in favor of this new syntax, right? We're going to be using let and const as opposed to var, right? But you still see var used widely, but surely we should move towards the more modern mechanisms. Okay, you can. We're also going to be using a JSON as the notation for working with data, right? So in JavaScript you can create objects, little objects, just like you can do a little string or little integer, right? You can also create a variable, let, and then a variable, and then use curly brackets, right, to declare an object, right, that you can provide properties of that object. And for instance, this object, right, there's its opening curly bracket, and that's the closing bracket. So let's play around with this. Let's declare here in source. Let's create a directory where we can play with ES6. And we'll create a JavaScript file, and we'll call it ES6.js. And let's declare a couple things. So let's see, we can declare this object. I'm gonna paste it in there. There we go. And say insert comment reformat code, so it makes it a little bit easier to read. Right, so there it is. So this is an object, and that has three properties. Let's see, it has an object property, it has an array property, and has a number array property, and this is an object array property. Right, you can name these whatever you want. Okay, and you can have objects embedded inside of objects. Right, so you can embed objects within objects within objects. So you can nest any objects indefinitely. You can make fairly complex objects, right, that contain other objects and whatnot. So for instance, here's an object, right? This property is an object because it has a curly bracket, and inside of that object you have two more properties, right? One of the properties is another object, right? So this is an object inside of an object inside of another object, right? And usually we want to display it this way so that it's easier to read. There we go. And so this object has three properties, 1, 2, 3. This object has 1 and 2 properties, and this one has 2 properties right there. Okay, so Q and W are properties of another object property. Make sense? Okay. You can print this out. You can say console log some object. There we go. And we can run it, right? We can go and let's see. We can go and stop that. We can say, let's go into source. Let's go into ES6. Let's see. So is Q and W an array? This Q, you mean? This Q right here is has a value of an integer, right? So properties can have values other objects. It can have arrays, or it can have little integers or strings. Right? So this could be a string. Okay. Okay. And so we can run this, and we have an object, and we can print it the console. So we can say run with Node, and you can say ES6, and there it is. So it prints it out. I don't know if I can make this bigger. It's fairly small. Let's see if we can. Let's go into. Maybe I can make this bigger here. Okay, so this is bigger, so you can see what I'm doing. So I can say node ES6. There we go. Yeah, so there it is. I'm running it from the command line, right? I can look at I can navigate through the object, right? I can say some object. I can go inside of a particular sub-object. There we go, an object property. We can print that. So notice that now I'm only printing the sub-object, which is this one right here, right? Because I'm printing that. I can go a little further. Maybe go into down here, right? So let's, so I can use the normal dot notation that you would be familiar with, right? So I can say dot, I can print that. There it is. Or just print out Q. Just 11. See that? One other thing that I did not mention in my documentation, in my slides, right, is that JavaScript you can either use the dot notation. You can use the dot notation, or equivalent is an equivalent syntax is that this can be an array. This could be an array like that. Okay, and then use double quotes, right? So this right here, okay, the equivalent is that you can use a square bracket notation, and it works just the same, right? So if you run it, you still get the same thing. Now this is important. This is going to become later very, very important, because this notation, right, in the dot notation, you're stuck with that property name. But if it's an array of a string, this string could be an expression that I can calculate on the fly, right? And that's very, very powerful, right? That's going to become very, very powerful a little later. Don't worry about this notation. We will revisit this again later. Okay. Let's keep going. Variables. So now variables don't need to be declared right there, right? You can instead declare the variables right when you need it, okay? And the scope will be whatever the scope you're in, right? So this let, right, has the scope of this for loop. So when you follow the for loop, the variable I is gone, the way you would expect it in any modern programming language, right? But before, you had to declare them all in variable. Functions, a lot of really great things, new things in ES6. So for instance, before, right, you would have to have this function like this, right, which is very simple, right? You can call add 5 and you pass 2 and 3, right? And we can and then we can, you know, const, you can print it out, log WQ. So we can run that. There's 5, right? So it's printing the 2 and the 3, and then printing out the 5, right? So this is very simple, right? You understand that. Now in ES6, we introduce a new syntax called the arrow function, right? So, oops, copy. So in ES6, an equivalent function, right, is as follows, right? Instead of having the parentheses like this, right? Notice that you have an equal and then the parentheses. Instead of having function, you don't have function, it's just a constant. See that? And then you have the arrow right here saying that this evaluates to the left-hand side is going to evaluate to the right-hand side. Okay. And so here, if we want to use it, let's use it now. Let me show you that it's identical. So let's call this let, and let's do that. And now let's run this ES6. Let's run ES6 with 2, 3, and the solution, right? The result is that you get identical, obviously. Let's see a question. Is this basically a lambda nanos function? Yes, yes. It's so common in JavaScript, right? It's so common that they wanted to have a new syntax that would make things easier to read, right? And you'll see how much better it is easier to read the code with this syntax, right? I'll show you in a minute. It's so much easier to read with this newer syntax, the arrow function. What is the difference between let? Okay, const means it's constant, right? Meaning that after it's been declared, you cannot change it, right? And let allows you to change it afterwards, right? So yeah, so let's now let's change ES6. So if now check this out, right? So you have ES6. Let me redeclare that function. Let me comment it out. Let me redeclare it. Now, if I don't have that line, right, and the only line is this return A plus B, right? If you have that case, which is very common, actually, it's extremely common that you have this, right? If this is true, the return function is optional, right? And the curly bracket is optional, right? So you can rewrite this as follows. You take out the curly brackets. You take out the curly brackets. Now you can take out the return. And it becomes this. See that? Again, this is much more terse, right? It's so much easier to read, right? So if I run this again, right, obviously you get the same answer, just 5. Okay, everybody good? Careful, right? This only works if you only have that one line, if you just have return, okay? Then you can replace it with just something like this. Everybody good? Okay, if you put curly brackets, careful, if you put curly brackets, right, that's syntax error, right? If you put curly bracket, that means that you want a body, right? You want a function body, and function body, this function body is syntactically wrong. You need an actual statement, which would be the return. Yes, careful, right? I'm sure this is going to be a quiz question. It was going to be part of your assignment. It was going to be part of your project, and a lot of people are going to, forget about this particular feature But this particular syntax, right? And they're going to be scratching their head. What's going on? Right? So careful, right? This only works, right, if this is true. You have a single line. You can do that, right? Otherwise, right? You can if you need that second line, then you need your return. You need your return. This is especially important. This is especially important when you're debugging, right? Notice that this is very hard to debug, right? Maybe you want to know what the values of A and B are, right? How do you check to see here? You can't put a breakpoint. Whereas in this syntax, you can put a breakpoint. So oftentimes, right, to debug, you have to change it back to something like this so you can put a breakpoint. Okay, so just be careful whether you're using one or the other. Okay, let's move on. Let's take another example. The other example here is that if you have a function, like say you have square, right? A function called square that you can say, you know, EWQ, you want to say square of 3, right? And you want to print out EWQ, okay? And let's comment out everything before. Oops, not square. Let's not comment out square. That's the one we're using. And let me just comment this one too. Okay, so say you want to run this in the square of 3, right? And so we're expecting that to be 9. There we go. So it's 9. Okay, no big deal there. But now let's implement that using ES6. So in ES6, this would be const square. This would be ES6, and this takes as argument b, and then this evaluates to b times b. Okay. Well, if this is a single argument, you can make this even more terse. The parentheses are optional. These parentheses are optional. Okay. And let's use it here. Let's use ES6 and square root of 4, the square of 4. Right, that gives you 16, what we'd expect. Okay, so notice that this is much less verbose, right? Much less verbose than this over here. Now over here doesn't look like much, but when you start using these functions as lambda expressions, it is very, very powerful. Okay, very, very powerful. So let me show you what this buys you. You know, this new syntax, what it buys you. Actually, no, not yet, not quite yet. Before, let's take a look at one thing that we had mentioned earlier. Let's see. So a function definition is saved as a constant. Yes. Yep. Yeah, that's we're declaring that variable. It is a syntax error now in not to declare a variable or a function, right, or an object before you use it. And the IDE and the browser will throw out, you know, error messages. Yeah, so before in ES5, if you remember, the keyword this did not behave as we expected in modern programming languages, right? We said that the keyword this was different depending on what context you were in, right? In when you were declared inside of a class, right? It had the keyword was bound to the outer function, but then using it inside of another function, it was bound to the inner function, right? And the way we got around that in the previous assignment is that we declare a self variable, right? That kept track of the original value of the keyword this, right? And then you can use self as a proxy of the original value for this, right? No such thing when you use arrow functions. If you use arrow functions, oops. If you use ES6, the keyword this means, right, its original value, right? It was bound to the outer class, outer instance when you instantiate. And if you're inside of a function, that keyword this is still bound to the original instance, right, that was instantiated when the class was declared. Okay, so excellent. So careful, right? If you write code that uses the old syntax, and or vice versa. If you write code that you're writing ES6 and you try to change it to the old syntax, the keyword this will have different meanings. So careful with that. Yes, ES6 this is just like Java's or C#, just like in line in line with other modern languages. It behaves the way you would expect it. Yeah, using ES6. And I would encourage you, right, that from now on, throughout the remainder of the semester, you stick to ES6 whenever possible. Well, I mean, there's no reason why not to. Default parameters. Let's see. So now, right, if you pass arguments, and for instance, you don't pass Y, you don't pass Z, right? You can pass, for instance, only the value for X, and you can leave out values of Y and Z. Okay, so you can default the value by providing an equal and declaring it right in the function. Okay. Or if you you might have noticed the language is typeless. Okay, it's not like we can declare things to be integers, floats, strings, objects. The data type of your variable will be implied. It will be implied by whatever you're assigning it. If you're assigning an integer, then Y is of type integer. If you assign it a float, then Y is a type float. So there's no declaration of the type. Right? For that, you would need TypeScript. Okay, we'll take a look at TypeScript a little later, which allows you to add type, like the name suggests, right? So it's a typeless language. It is implied on the fly. Okay, let's look at arrays. Okay, so here's you can declare arrays. Let's see, let's comment this out. Like you would expect in any other programming language, right? You can say square brackets and then the values in there, and you can declare arrays of anything, right? Arrays of integers, arrays of objects, arrays of whatever, right? And so here's a function that one of the coolest functions, or several functions that are part of the language that allow you to manipulate arrays, right? For instance, filter is a function that what it will do is that it will loop over the values in the array, and it will call a function that you provided. Okay, and that's a function, right? That's a lambda function. Notice how terse and very compact that is, right? That is a function that takes as argument a variable I, and it returns whether this is true or not. Okay, it's doing modulus I modulus 2. Is that equal to 0? If it is, then it's even, right? If it's not, then it's odd. And notice that filter is going to iterate over all of them, right? And it's going to keep all of the values in all for which this returns true. So you can quickly iterate over an array, right, of objects or anything as complex as you want, right? And then you can write logic in here to say, well, I want to keep this, I don't want to keep that one, I want to keep that one, and whatnot, right? So let's do that. Let's print out. Let's do console log even and odd. Let's print out odd here. Okay, so let's run that. So there it is. So there's the even and there are the odds. Okay. So notice that the version, the ES6 version of this, let me write the ES6 version of this. See how complex it would be, right? It would be this. It would be function, right? It would be parentheses, right? And this would be curly brackets, curly bracket. There we go, right? And then it would be a return. Return that. Okay, so notice that is so much harder to read, right? You could put it as a separate function, right? You could put it as a separate function, but why would you put it as a separate function if this is so much easier to read, right? It's a function that you're not meant to use ever again, right? It's embedded in there. It's not, you don't need to litter the namespace, right? It's very, very compact. Are functions objects? Yes, functions are treated just as any other variable, right? So wherever you can pass a variable or little string or integer, you can also pass an object, right? And then you can ask that parameter, what type are you? Are you a number? Are you a function? What are you, right? And then execute it. And then if you know it's a function, then you can invoke that function, right? You can execute that function internally. In Java, they're not. So yes, filter. Filter requires a predicate object. Filter requires a function, right? And that function returns true or false. Yeah. So filter takes as argument a function. Yeah, and that function is expected to return true or false for all the elements that it passes, right? So it's passing each one element. So we'll see lots of these versions of these functions, right? So this is ES5, and this is ES6, right? So we're going to prefer this new syntax, right, as opposed to the old syntax. Let's see. Yeah, so this is showing you the difference, right, on how you would do it using ES6, the new modern way of doing it, and the old ES6 way of doing it. Let's see. Yeah. Oh, okay. Yeah. So careful. Here's to be careful. If you write this, right? Say you want to print out the value of I as you're iterating. Say you want to change this to so that as you're iterating, you want to print the value of. How would you do it? Okay, so you would be, so you can't do this. Careful, you can't do console log I semicolon. Right, this is a syntax error. See that? It's complaining. Then the next thing you might want to do is says, oh yeah, you're supposed to put this in a curly bracket. Notice that the IDE kind of botched it up. It doesn't know where to close the curly bracket, right? So the curly bracket would need to be closed where? Right here, maybe, right? Okay, it's still wrong, right? So because this is not a syntactically correct expression. Well, the expression is correct, but you need to do a return. There's not a statement. Okay, now it's properly converted into a multi-line function, right? The first version was like this, where it was a single line. It was we call this an implicit return, right? It's implicitly returning all these every time the function is being invoked. So this function is invoked every time for every single element in the array. And every time it's invoked, it's returning whatever that is, whatever that evaluates to, right? We're expecting it to be a Boolean, true or false, yes? And so, yeah, so this is an implicit return. Now here, it's not implicit. You have to explicitly add the keyword return. Make sense? Okay, so if we run that, notice that indeed it's iterating, right? It's iterating over all 10 elements, of which it's only keeping 5 of them. Only the ones that are even. Make sense? All right. All right, so let's keep going. Map. So map is another very useful function that, again, iterates over the arrays, but what it does is that it accumulates all the values that it returns. So for instance, let's take this example of over here, all. I am overriding the value of all. It used to be 1, 2, 3, 4, 5, 6, 7, 10. So I'm just going to do only the first 4. So what it does, right, is that it iterates over each value in all, and as it iterates, it calls a function. Here it is again, right? It's an ES6 arrow function. Yes. And then whatever that function returns, it accumulates all those values, right? It accumulates them. So that the result will be the accumulation of all those results. In this case, you give it an array, it's going to come back with a brand new array where the values of that array will be the squares, right? The square of 1, the square of 2, 3, 4, so on and so forth, right? So let's console log all here. Right, so let's print that out. There it is. All right, these are all the squares. 1, 2. Oh wait, that didn't work. Map all. Oh, I'm sorry, square. I want to print out the squares. Yeah, so let's print out all, and then the squares. squares. I guess a better name is squares. Right. And I think you can put a string in front of it, right? So all, and you can say squares, just so that you can print out and keep track of what's going on. There it is, all in squares. Okay, like for documentation for yourself. All right, so let's keep going. We're going to be using this a lot. All right, this map function, we're going to be using it all throughout the semester, right? So it's one of the most useful functions, right? Especially for React.js applications. So it's extremely, extremely useful. We're also going to be using filter, and all these are going to be, our bread and butter for the whole semester. There's also all the really good, really cool functions that allow you to find an element, and it returns the element, right, which meets the criteria. The first element that meets the criteria, right? So for instance, I'm iterating over this array, and here it's iterating over the array, and the first one to return true, that the value is greater than 3. So for instance, 1 is not greater than 3. 3 is not greater than 3. When it gets to 4 and it's greater than 3, boom, it's done, right? It comes back with the value 4. You can also find the index. Where did you find that? Is it at index 0, 1, 2, 3? What index, right? So it found it in index number 2. So 0, 1, 2. And then filter, again, we saw that already, right? It filters all the values greater than 3. So in this case, it would be 4 and 5. Okay. My question on the chat. Can map create a new array in different size? No, but we will learn how to create bigger arrays. Yeah, it cannot resize the array. No, it creates a brand new array with the same elements, but with different elements. But we will know how to do that. Yes, we will learn how to do that. Also, interpolation, right? We used these backtick, right? Now these are templates, right? That we can make a string that is a very long string, right? And then we can embed inside of that string expressions, right? Expressions using the $, right, and the curly bracket, right, to then refer to variables or objects. So for instance, this is customer.name. So this would be customer.name is equal to Alice. So this would say, hello, Alice, comma, want to buy, and then card amount. So card is this, amount is 7. So want to buy 7 car products. So bar. So, can you buy 7 bar for total of card number? Notice here that we are using some mathematical expression, right? So this whole thing is an expression that can be evaluated on the fly, right? So this is an amount, 7 times 42, whatever that is, right? Console log message. So very, very nice. We used that in the previous assignment in jQuery, right, to create a row. Array matching. And so if you're giving an array like this list of numbers 1, 2, 3, right, and you want to extract values in ES6 and in many other languages, the same thing, right? You can just say list of 0 or list of 2, right, to extract the values of A and B, right, by knowing the index, right? So ES6 introduces this syntax, right? It's called destructing. Just like you have a constructor to put data inside of a data structure, destructing is the inverse, right? You want to extract data from a data structure. Data structure could be an object, an array, right? Some complex data structure, right? So here's for arrays. So say you have an array of 1, 2, 3, you can now use this syntax where you assign the list to an array like that. So this is declaring variables A and B, for which I am extracting for A, the first element of list, and B, I'm extracting the last element of list, right? So I can print out A and B. So let me show you. Let me show you this over here. So if I declare, and this could be let or whatever, let, and then we can print out, you can say console log A comma B. So if we print that, So we can print out list and then A comma B. Let's run that. So there it is. So A, so this is the list, 1, 2, 3, and then A is 1, and then B is 3. So it extracts the values. You can even assign to each other, which is pretty cool, which allows you to like inverse the values, right? So you can swap them. Normally to swap, you would have to use temp, like a temp variable, right, to then swap values. Well, now you have this syntax where you can just swap them around. So let's swap them. Actually, let's do that and then that. Let's run. Oops. Can now play undefined. Interesting. Maybe I wrote it wrong. Chat. Is the double comma there on purpose? Double comma. Do I have a double comma? Where's the double comma? Oh, this double comma. Yeah, this double comma allows you to skip this 2, right? So I want to grab this 1 and make it A. I don't care about the second element. I don't care about 2, and then I want to grab B, this 3 over here. Yep. Yeah, you can do the same thing, but now for objects, you can say objects here. So for instance, if you declare this variable, this object, again, let's use let, and you can extract, we can extract, oh, this, I guess this would be temp. Oh, I meant to say temp here. Temp. So you can say, let Q comma W, right, equal temp. Okay, and then you can say console log Q and W. So what's going to do, right? It's oh, I'm sorry, I don't have a QW here. Let's call this Q and let's call this W over here. So what's going to do, right? It's going to extract only the pieces that you want from an object, right? So this was for an array. This was for an array and was extracting by index, by position, right? So A is in the first position, so it's 1, and B is in the second position, third position, I guess. So it's 3. Here it's by the name of the property. So I'm extracting Q and I'm extracting W, right? So if I run this, right, notice that I extract 235, which is Q here, and 3, 4, 5, 6, which is W. See that? So that's destructing, or so extracting data from a complex data type. Okay, very, very powerful. Again, we're going to be using that a lot, right? Especially in functions. Like for instance, this function. So check this out, right? So for instance, if you pass in an object to a function, so here's a function, and you want to pass a function, an object. See this? This is an object. So arg has now this object is equal to this object. And if you want to extract from arg, you can extract the name. So this becomes var, bar. So name becomes bar. And I'm extracting from argument, I'm extracting val in here, right? And then I'm just printing it. Yes? Well, using the destructor syntax, you can rewrite that as follows. Much, much cleaner, much more terse. So I'm notice the curly bracket here. I'm passing an object. And because I know the names of the properties that I want to destruct, that I want to extract from the data structure, this is name gets the value bar, and value gets the value 42, and then I can print that out. Right, very, very powerful. Can you grab more than 2 attributes that way? More than 2 attributes. I mean, here we are, right? We are grabbing more than 2 attributes, right? Is that what you mean? Not sure. Yeah, you can grab any number of attributes. So you can also rename them. If var q maps to props q in JSON object, can I name the variable name or to something else? Yes, there we go. you can do this, right? You can pass name and value, and you can locally rename them to something else, right? So that internally, right, you can use a different set of names internally in your function, right? So you can rename them using the colon operator. It also works with arrays. So you can pass an array, right? So you can grab the first element and then the second element and then use that instead. That works by index. So my question was parameter matching, regarding parameter matching. So my question was regarding parameter matching. Yeah, not quite sure what you mean. Is the queue maps to props queue in JSON object? Can I name the variable name to something else? Variable name. You mean if I can call this something else? So if this is a name, can I call this something else? Is that what you mean? In your example, only yeah, no, they have to match the name of the product. So this is using, so the array is using the index, okay, not the name, but here we're using the actual name of the property to retrieve it from. Yep. Property shorthands, you can, this is something very common as well, where you are building an object, right, that you have a property, and you're giving a value to that property, right? So say you have X and Y, and you want to create an object that has a property X with a value of X, and then a property Y with a value of Y. Well, you can have a shorthand for this syntax, where you can just say X comma Y, and that's it, right? By doing this, it knows that the name of the property and the name of the variable have the same exact name, right? So you can use that shorthand. Again, we're going to be using this quite often in the syntax. Modules. So now in ES6, you have full access of full-blown modules, right? That can be exported and imported, right? In JavaScript, typically the way you bring in new code is that you do a script, right? And you get the source and you read that module or that file, you read it into scope. Here you have a much more powerful mechanism, right? The old mechanism, loaded all the files into one single namespace, right? And so any variables, any functions that each one of those JavaScript declared, then it would litter the namespace. I'm sorry, I have somebody at the door. Let me be right back. Sorry. Sorry about that. All right, so yeah, in the new version of JavaScript, you can now break up your application into multiple files, just like you would in any regular Java program. But now, you can have, these dogs are gonna kill me. You can have those libraries export only the code that you want other libraries to see, but everything else in that file is now private to that file, right? No, you can't, no one else can see that unless it's explicitly exported. So for instance, in math.js, right, if you have a library and you're declaring all sorts of functions like sum or pi or useful constants, no one can see what's inside of the file unless you export it explicitly, right? As opposed to in the old version of JavaScript, any function you would declare, any variable you would declare, if you load it through script, anybody can see that function. Here, they are all private unless you explicitly export it. Okay, then if you do want to use somebody else's functions or variables, you can import it. You can say import, and you can say, well, import everything. Everything that has been exported, I want to see it. And then you can give it a local namespace so that you can then use math.sum, and you can give it any name you want. You can rename it to M or something, M3 or something, whatever you want, right? And then you can use any of the functions that were explicitly exported, right? So this is going to be a mechanism that we're going to be using all throughout the semester, right? Of writing small modules that they can then be reused to build more powerful things, right? Now you can also, instead of importing everything with a star, okay, what you can do is that you can import using the destructor, right? You can destruct whatever it is that you are importing, and then you can say, well, I don't want everything. I only want these certain functions or these variables, by using the destructor syntax, using curly brackets and whatever it is that you want to import, right? Very, very powerful. You can now, yeah. So the star. You can also export something by default, and what we mean by default is that here you have to either give it a namespace or explicitly say what it is that you're importing, right? But now there might be a function in there, right? There might be a function which is maybe the main function of a module, right? That that you can declare as being the default export, right? The default export, so that when you import it, you don't need to destruct it. You don't need to destruct it. You just give it the name of whatever it is that you're exporting, right? And you have it right there. It's just a convenient way of importing without having to destruct, right? And so it makes the code much cleaner. And we'll see plenty of examples there. Is the pathing from the root of the project? No, it's relative. It's from wherever you are in the code there. Default. Okay, classes. So now classes are fully supported, not like the fake classes like we had in ES5, which were it's prototype classes, prototype inheritance. These are full-blown classes, just like you would expect in any modern programming language. Okay, very object-oriented style, boilerplate, free classes. Okay, so the syntax is like as you would expect. You have class, and then the name of the class, and you have a constructor like you would, but it is with using the keyword constructor, not the name of the class. So constructor, and then the parameters that you would expect. Now then you can bind those parameters that are being passed to local variables to the current instance by saying this dot and then the local instance. And then you can refer to any functions that you would declare locally inside of that class, right? Where you can refer to the values of x, y, that are already bound to the current instance. Okay. You can also declare. You can now inheritance. Now this is true inheritance, not the prototype inheritance of ES5. This is you're inheriting all the like you would expect, right? You're inheriting the constructor. You're inheriting any functions. Methods are declared at the superclass. So you get so say here you have rectangle and circle are both extending shape from up here. So you are inheriting the move. You are inheriting the constructor as well, and you can make use of methods that you inherited from your parent. Right? So you can call the move function, right? Because because you've inherited from your parent shape. Okay. You can also call the super constructor, right? So you can, for instance, call the shapes constructor, pass it any variables that the shape constructor needs, right? Pass it whatever that is, right? Whatever it needs. Plus, you can then declare local class variables like you would expect. Right? You can also have setters and getters. This is very much like C#, right? Where you declare variables, right? That you can then invoke either by passing an argument and treating it as a function, and it knows that it needs to set the value of the local variable, or you can read the value by just saying with. Okay, you can treat it as a function, or you can treat it as a variable too. Like for instance, here's area. Area here is using is saying you're assigning or checking to see the value of area. Just instead of saying get, right, or set like you would in Java, you can treat it as if it were a variable, right? And if it's being used in an expression like this, it would use the set. It would use the get operator, right? This would say get with and would read the value of area or whatever, right? If instead you're assigning it, saying area equal 1,000, then it would be using the set, right? The set area. Well, you would not set the area, right? You would set the width and the height. Okay. Let's see what else. You have static members now. You can declare a variable or function to be static, and it'll be behave just like you would expect any other language, right? It's a variable that stays with the class, not with the instance, right? And you would access it by using the class name. Subclasses, right, can subclasses that have extended a superclass can use functions that are declared in the parent class by using the keyword super dot, and then you can call the functions declared in your parent. So this is just a really quick introduction of ES6. We're going to be introducing even more features as the semester progresses. Like for instance, the spreader operator, right, for being able to copy objects, to do deep copy, shallow copy, add things to the append things to the array. Do all sorts of things that we're going to be introducing as we progress. Okay. All right. Any questions before we introduce React.js? All right. All right. So let's talk about React.js. Yeah. So let me just give you a little bit of context, right? So React.js, you can learn all about React.js at reactjs.org, right? And I encourage you all to visit this website, right? So let me just copy here a couple things that you should be familiar, and I'll paste it on the chat. All right, so definitely you should go over some of the Node.js for installing Node.js, and you should go to React.js as well to learn about React.js, right? So all the documentation is there, and you should become familiar, at least for what's there, right? It has plenty of tutorials, some really simple tutorials you can get started on. Although we're going to be doing those tutorials here as well. And they're going to be heavily based on the assignment that we're going to be releasing soon, right? That we're going to be working on soon. Okay. It uses all the syntax that we've used so far with the new versions of ES6, but it also uses a new syntax called JSX, which we will introduce later today. So let me show you. Let me show you the application. So this application, we ran it already, and it's running somewhere. There it is. Okay. Okay. This is the boilerplate application that they give you. Okay. And so React.js, it's not a framework per se. A lot of folks feel, oh, it's a framework. No, it's not a framework. It's a simple JavaScript library. You're very much like jQuery is a library, right? And it has the just like jQuery has a purpose for making it easier for folks to work with the DOM, right, and be able to manipulate the DOM with a nice API. What React.js does is also a library that is used for creating user interfaces, right? And but it's a library for creating what are called single page applications, right? Single page applications. Now, what we mean by that is that many of the applications that we use today, right? Say maps, right? So you go to maps, right? I think maps for me was the first single page application that kind of opened up my brain and says, oh my goodness, right? This is so much better. So I don't know if anybody remembers MapQuest, right? MapQuest, yeah. MapQuest originally was not a single page application. Now it is. Now it's a single page application. But at that time, it was not a single page application. What we mean by that is that the way MapQuest was implemented was that was using the old school implementation, right? So for instance, if we wanted to implement this, and I want to zoom in, I would click on some button that you would click to zoom in, and what the application would do is that it would kind of throw away the old page, right, and would fetch an entirely new map, and then it would re-render the entire screen. Even though a lot of this part of the screen was static, right? There was no need to throw away that part, right? Certainly the button there was no reason to throw away the button, right? Because I was going to use the button anyway again, right? Especially maybe some commercials here, some ads, some other stuff, right? There's only some part of the content that is changing, which is the map. The map is changing, but a lot of the content is not changing. Why throw away the entire document, right? And then re-render the same thing, right, for this left-hand side, and then only have the map change, right? So MapQuest was implemented this way. It was the standard way of implementing it back way before single-page applications came into the scene. And so same thing if I wanted to pan right, pan left, right, or anything, right? It was always throw away the whole thing and then re-render the whole thing again, right? So what Google Maps introduced was a very smooth way of interacting with the application, right? That allow you to very nicely and very smoothly just interact without this jarring, re-rendering of the entire document. Okay, and the way they implemented that was that they said, you know what, instead of navigating, because the old implementation was, let me throw away the content, let me navigate to a new HTML document, right, that has the new content, right, that was maybe dynamically generated, but it had like a flickering, it had a jarring effect. Whereas single page applications, what they do is that they load the main content, the first index page, right? They load the first index page, and then they never reload it again, right? They use JavaScript to dynamically inject content, right, into that using, for instance, $, using jQuery HTML. Remember jQuery.html? Well, that allows you to dynamically inject content into whatever element you have, or append, right? Allows you to dynamically add content down below without having to re-render the entire document. Yes. So this mechanism of JavaScript and jQuery allowing you to dynamically manipulate the content, right, without reloading the whole thing, right, is what we mean by single page application, right? So let me give you an example of what React.js does. So React.js, what it does is that it has a single page, this one, index.html, right? And that index.html, if you look at it, there's what? Let's see. We have an HTML, we have head, we have body, there's a no script, and there's div. There's nothing else. That's it. That's all there is. Div and root. That's all your index page has. Okay. Now, if you look at the DOM, let's look at the DOM. If you inspect and you look at the DOM element, So there's HTML, and let's look at this. So if we have head, you have all that. So head, yeah, you have all those meta. See meta, same meta, right? Meta, 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 right? We have all these links. You have the meta, the links. There we go, right? And then there's a body. There's a body. There's a body. That's the body here, right? There's no script. There it is, no script. And then there's our div root. See that? There's our div. But here it's empty. There's nothing in there. But notice that this instead has content in there. See that? It has app. There's a header there. There's an image that is rotating. Okay, there's a paragraph, which is this paragraph over here. So where does this all come from? Right? It has been dynamically injected into that div using things such as jQuery.append, jQuery.html, right? So what React did, right, is that just like jQuery is a layer on top of the browser, well, React.js is a layer on top of jQuery, okay? Creating an even higher level of abstraction that plays into that mechanism of being able to dynamically inject content in there. Let's see, what do you have? Was Java Spring a single page application? So Java Spring, what we built in the user admin page that is due on Wednesday, right? That page, that HTML page, is a single page HTML document, right? In the sense that you can create users, you can delete users, you can update users, right? And the page is changing, it's increasing and shortening, it's changing over time, the content is changing over time, okay? Without re-rendering the entire document, right? And just like you're implementing that user admin page, that just like you're implementing that, it is the basis on, is the core technology, right? Well, obviously it's a very rudimentary implementation of, if you go to Twitter, all the twitter.com, the rendering of this document, right, is being done using that technique. It's going out to the data, to the server, and is retrieving data, right? It's retrieving data, and it is dynamically rendering this, append. It's iterating over data that is coming from the server, and then generating a content, right? Here, right, dynamically. So in that sense, the user admin page that you're creating for that's due on Wednesday, it is a single page. It's a single page. Obviously, now if I go to profile and notice that it did not render. See that? It did not. There was no jarring, navigating. The content here was dynamically cleared off, and then it was dynamically re-rendered using JavaScript. There was no navigation. There was no throwing away, right? So an entire application is built that way. We are only applying it to the user admin page, but imagine that applying it to an entire application, right? Yeah, same DOM, different, same DOM. Well, no, we're manipulating the DOM, right? The root is the only thing that survives, right? The root here is the only thing that survives, and our responsibility is to tell React.js what do we want to show in this root, right? And so using navigation, using all sorts of mechanisms that we will be introducing, we will be updating the DOM, staying in the same root, the same URL. Notice that we haven't changed the URL. We're navigating messages, bookmarks, right? Well, I mean, we're changing it only to show you where we are, right? But notice that it's not refreshing the page, not throwing away the content. It is dynamically updating just the root element, okay? So that's what we're going to be focusing for the next 2 months, right? Of dynamically updating content using libraries such as React.js, okay? All right, just a quick note here. Let's see, we have app.js. There's our index. See that index? So all the code is really under source, And here's the entry point of our React application, which is going to be a little bit weird, but let me just show you a couple things that you might be able to, that you should be able to identify from what we just discussed in ES6. Notice the use of imports. See that? Lots of imports, meaning that these files are being, presumably they're exporting something that we are then importing here, right? Let's go into one of them for now. Let's go into one of them. Let's go in app. Oh wait, just a minute. Let me go back. So here's where the magic begins. See this root? See that root right there? That's where the magic begins. It's that is referring to this div whose ID is root. See that? So there's where it's saying, hey, in that root, in that element whose ID is root, I want you to inject this, however that is, right? However that happens. We'll see in a minute how that works next time we meet. But let's look at app. Let's go look into app here. Let's go into app. What's in here? Ooh, look at that. There's a div, headers, an image, the paragraph, the hyperlink. So this is the content. This is the content that we were looking at 2 seconds ago. Where is it? Right, there it is. That code, that edit, that app logo, that image, that header, it's coming from app. It's basically a function, right? It's a JavaScript function that returns the HTML that you want to inject in there. See that? Right? It's a function that returns the content that you want to go in there. So basically what React.js is going to be is just a whole bunch of functions, right, that you can then programmatically decide what content you want by calling different functions, and then that whatever those functions return is what's going to be injected into that content. Okay, and now obviously the same questions of software engineering apply. How much are your functions, how granular your function should be, how big your function should be, right? That's all software engineering, right? Of how modular, how granular you want to be, or how coarse. Functions can call other functions, right? So just like you can break up a big problem in any software engineering challenge, right? One big main function is written in terms of 10 other functions, and each one of those is written in terms of other 2 or 3 other functions, and you can break up a large problem into many smaller problems. Same thing here, right? We're going to break up all this a big application into small, little, tiny, small functions that can then be invoked to render small snippets. Make sense? Also, I want to point out here is that notice that we have kind of a lot of JavaScript here, right? And all of a sudden we have HTML. And then down here we have JavaScript again. See that? Well, that's a new syntax. We haven't seen that before, right? That we can seamlessly go back between JavaScript and HTML backwards and forwards, right? So this is a new syntax called JSX, right? JSX, allows you to embed, right, seamlessly between JavaScript and HTML, right? And so we're going to be using this quite a bit. If we didn't have JSX, we would end up having lots and lots of backticks and double quotes, single quotes, just like we did in jQuery, right? In jQuery, to be able to have jQuery had HTML embedded, we had to escape it using the backticks. Remember that, right? And then we could have like one big HTML instead of the JavaScript, right? But that's not good practice, right? Usually, you want to use technologies such as JSX, or not allow this at all, right? But JSX is a nice technology that allows us to, straddle between these two worlds, and it's going to be very, very interesting, very nice. All right, so I would ask you to please take a look at the slides for Wednesday. So on Wednesday we're going to be talking about the slides for week number 4, as well as we're going to introduce the third assignment, A3. Right. So if you could if you could read through all those slides and the next assignment, and if you can bring questions, we can move forward next Wednesday. Okay.
Professor?
Yes.
I had a doubt with respect to the project. I just
Yes, please go ahead.
want the what is there a different stack for the project? Is it like React and Java Spring, or
Yeah.
React and Node?
Yeah, you can. So in the assignment is very strict what the technology stack you use. In the project you can use whatever you want. You can use React or Vue or Angular.
Okay.
And for the middle tier, you can use Java, Spring, or Node.js. And for the database, you can use a relational database such as MySQL, which we're going to be covering. Or if you prefer to use a non-relational database such as Firebase or MongoDB, which we are going to cover.
Okay.
Right, but you're free to choose whatever stack you want.
Okay. Thank you.
Okay. All right. And it seems that I have no access to ES6 slides, but other slides are accessible seamlessly. Oh, really? Okay. All right, I'll fix that. Share. Change to anyone. Okay, now you should have access. Please confirm if you have access. All right, so let me know. All right, if you don't, let me stop the streaming. Awesome, great, thank you. Stop share and bye-bye, everyone.